Space travel is one of humanity's greatest achievements, but it's not all exciting rocket launches and breathtaking views of Earth. Beyond the glamour of space exploration lies a dangerous, hostile environment that tests the limits of human endurance and technology. Welcome to my channel, everybody. In this video, we're diving into the 5 scariest realities about space travel that astronauts face. Let's get started. The first terrifying reality of space travel is cosmic radiation. Once astronauts leave the protective shield of Earth's atmosphere and magnetic field, they're exposed to high-energy particles from the Sun, as well as distant stars and galaxies. This radiation comes in 2 forms. The first is solar particle events, or SPEs, which are bursts of radiation caused by solar flares or coronal mass ejections from the Sun. A single solar storm could expose astronauts to lethal doses of radiation in hours. Then there are galactic cosmic rays, or GCRs. These highly energetic particles travel from outside our solar system and can penetrate spacecraft walls. Over time, they increase the risk of cancer, cataracts, and even damage to the brain. Even with shielding, it's impossible to fully protect astronauts from radiation during long missions, like a trip to Mars. NASA estimates that a round trip to Mars could increase the lifetime cancer risk for astronauts by at least 5%. Living in microgravity may look fun, but it comes with serious consequences for the human body. Without the constant pull of gravity, astronauts experience bone density loss and muscle atrophy. Here's how it works. In space, bones lose minerals like calcium at a rate of about 1% per month. Over a 6-month mission, astronauts can lose up to 10% of their bone mass, making them more prone to fractures when they return to Earth. Muscles weaken because they don't have to work as hard in a weightless environment. Even with 2 hours of daily exercise, astronauts still lose muscle mass during long-term missions. The effects of microgravity don't just stop once astronauts return home. It can take months or even years to fully recover. Space travel isn't just physically demanding, it's mentally exhausting too. Imagine being confined in a small spacecraft for months or even years, far from Earth, with no way to escape. The psychological toll can be immense. Here are some of the key challenges astronauts face. First, isolation. On long missions, communication delays with Earth can stretch up to 20 minutes each way. This means astronauts must make critical decisions on their own, with little immediate support. Next, monotony and stress. Living in tight quarters with a small crew, performing repetitive tasks, and dealing with constant risk can lead to significant stress and even depression. Then there's sensory deprivation. Without the natural cues of day and night, astronauts often experience disrupted sleep cycles, leading to exhaustion and irritability. NASA and other space agencies invest heavily in psychological training and support systems, but the mental strain of space travel remains one of the most difficult hurdles to overcome. Spacecraft are marvels of engineering, but even the slightest malfunction can lead to catastrophic outcomes. The vacuum of space is unforgiving. There's really no room for error. One of the most famous examples is the Apollo 13 mission in 1970. An oxygen tank explosion forced the crew to rely on their ingenuity and limited resources to survive. Against all odds, they made it back to Earth safely, but it highlighted just how fragile space missions can be. Other risks include life support failures. Systems that regulate oxygen, temperature, and pressure must work perfectly. A single failure could be fatal. Space debris is another big threat. Even a tiny piece of debris traveling at thousands of kilometers per hour can punch a hole in a spacecraft. System malfunctions, from propulsion systems to navigation software, can leave astronauts stranded in space. Despite rigorous testing and backups, no mission is ever 100% safe. The journey back to Earth is one of the most dangerous parts of any space mission. When a spacecraft re-enters the atmosphere, it must endure extreme conditions. First, heat. the spacecraft's exterior heats up to over 1,600 degrees Celsius or about 2,900 degrees Fahrenheit due to friction with the atmosphere. Heat shields must work perfectly to prevent the spacecraft from burning up. Second, G-forces astronauts experience intense gravitational forces during re-entry, which can really strain their bodies, especially after months in microgravity. Third, parachute deployment. A malfunction in the parachutes or landing systems can be disastrous. Even with modern technology, landing safely is never guaranteed. For example, during the Soyuz 11 mission in 1971, a depressurization event during re-entry tragically killed all 3 cosmonauts on board. While safety measures have improved, re-entry remains one of the riskiest phases of space travel. Space travel is one of humanity's greatest achievements, but it comes with incredible risks. From deadly radiation to psychological challenges and the constant threat of malfunctions, it's clear that space is not a place for the faint-hearted. Yet despite these dangers, astronauts continue to push the boundaries of exploration, paving the way for humanity's future in the cosmos. Which of these realities surprised you the most? Let me know in the comments below, and don't forget to subscribe for more fascinating science content. Thanks for watching. I will see you in the next video.